Hello, everyone. This is another study of Oahspe.com podcast video, copyright for YouTube. Today's subject is part two of Cevorkum, sub-galactic orbit of the solar system. Now, in the Oahspe glossary, there is high Dan, highest light, and high Dan sun, north star. High Dan vortex, the vortex of the North Star. Now scrolling down, and I'm on my page Space Clouds, Earth Travel Arachnobuagla, and I'm going to do a recap of some things that I went over on the last video. Now right here it says Oahspe Book of Wars Against Jehovah, chapter 37, verse 7. The cycles of the sun and the cycles of the sun's sun, the north star belt therein, and the vortices that move them all. And there is a picture, an artist concept shows two class F stars, supergiant Polaris A and the companion Polaris B, right there. Polaris, center of Cevorkum, the master sun, the sun's sun, right there. So as I said in the previous video, Nibiru is not the sun's sun. It is Polaris, the sun's sun. And right there it says the bright supergiant Polaris. Polaris is the white supergiant star which is around 50 times the size of the sun. Polaris mass. Polaris is estimated to have a mass of around 4.5 times greater than that of the sun. This is the sun's sun, Polaris. Polaris is similar to the surface temperature of the sun. Polaris has a luminosity around 2,500 times greater than that of the sun. So that would be the high Dan, or the highest light of the sub-galactic vortex of the orbit of the solar system. The central sun, or the master sun, Polaris, which has a luminosity, high Dan, high luminosity, high light, around 2,500 times greater than that of the sun, according to astronomers. So there you go. That's the sun's sun, Polaris. Now, as I said in the previous video, there's a book called Our Universe is Thicker Than Blackberries, and above, right there, is from the book Our Universe is Thicker Than Blackberries, Discourses on Godel Magic by Martin Gardner, 2004. And in that book, on page 108 of the above book, the author makes a common mistake I've heard. He states that according to Oahspe, our solar system travels in an orbit around the Milky Way galaxy that takes 4,700,000 years. This is false and a failure to understand Oahspe. The 4,700,000 year orbit of Cevorkum that Oahspe speaks of is a sub-galactic orbit around the North Star Polaris, not a galactic orbit around the Milky Way. So there's that, a recap. And right here, you have Google galactic year. And the galactic year, also known as a cosmic year, is the duration of time required for the solar system to orbit once around the center of the Milky Way galaxy. Estimates of the length of one orbit range from 225 to 250 million terrestrial years. Galactic year, Wikipedia. Now, as I said before, the term sub-galactic orbit is a rare term, because when I did a Google search in July of 2016, the only results of that were websites that were from my website, studyofoahspe.com, with the exception of one that did a joke, that was joking about the people on these programs are phenomenally dense. So dense, it is not beyond the imagination that they may, in fact, be the center of a sub-galactic orbit. So they used the term sub-galactic orbit in a joke, referring to people being phenomenally dense. But all the other references were from pages of my website, as you can see there. And then one reference from a website by Robert Bayer, who refers to my website. Matter of fact, that text right there, the travel of the Earth around the galaxy Gala, the subgalactic orbit called Cevorkum. The roadway has certain nebulous Nabu. That's a quote from my website on the definition of the Arachnabuagala, which is based on Cevorkum, the subgalactic orbit. So it's a rare term, and I first saw the term subgalactic orbit in reference to our solar system from Removing Oahspe's Enigma by Jim Denon, as I said in the previous video, and that was from Jim Denon, September 1979, and I provide links to his work. And there is a work by Jim Denon, 1979, Cosmic Times and Seasons, and the picture of Jim Denon and his mother. And I discuss below is astronomical evidence that our sun is in a subgalactic orbit around Polaris, the North Star. And what I added to my website was this picture I took of the motion of a snake, which is a serpent, in the sand, as you can see right there. That probably was his head, and there's his body undulating right there and there, with these black lines pointing to parts of the snake's body impression that I added. And then it says here, above, snake serpentine motion recorded in the desert sand of Southern California. Notice similarity to solar system motion right here. And then here's a plate right here called deviation of the line of the solar vortex, road of travel, serpent's orbit of the vortex Tau Sang or solar family of the Great Serpent. See, the solar system is called the Great Serpent in Oahspe, I believe because of its serpentine-like motion or snake-like motion. As you can see right here in this snake-like motion recorded in the sand, and you can see BB right here of this plate is the deviation of the vortex from a straight line. So this deviation or undulation is very similar to this undulating form or motion of the snake. And D and D on the plate, on the image, are Dan. From D to D is 3,000 years, or from one dawn of Dan to the next dawn of Dan. And it shows how the Great Serpent, the solar system, undulates in a wave-like, sine wave-like motion up and down. And basically you have what appears to be from one trough or top of wave to the next is about 3,000 years for it to complete its cyclic motion. And that plate came from Oahspe Standard Edition. That image of that plate came from Oahspe Standard Edition, which I have a link to right there. And as you can see, that snake-like motion recorded in the sand and that solar system Great Serpent motion of the deviation line of the solar vortex plate is very similar to this motion right here around the Milky Way galaxy, showing the solar system in a serpentine-like motion, which each one of these up and down cyclic motions is basically one arc cycle, or from Dan to Dan, as pictured there in that plate of the deviation of the line of the solar vortex. From Dan to Dan, right there, you see it goes from one high point to a next high point. That's basically one arc cycle, or one sub-galactic orbit. And right there, there's an image showing the solar system and the Earth cyclic motion, which shape looks like that of a snake. Scientists, astronomers recognize that the sun following a short wave-like path that takes it above and below the galactic plane. And there it is right there. And I believe this motion, the cyclic motion, represents the arc cycles of Cevorkum in the sub-galactic orbit of the solar system. And right there you can see wave-like path equals spiral circular sine wave motion equals crest to trough equals half circle or diameter. So you can see right there as it undulates up and down and moves in a spiral sine wave motion, it also moves in a circular motion. So crest to crest or trough to trough equals full circle, circumference, or orbit. Cevorkum, Cevorkum. And that's the same as what is pictured there in still images and what you see here in an animation. And there's an image right there of a cycle, a sine wave cycle from crest, the top, to trough at the bottom. And as I showed before, there's an image of the solar system right there. And there is right there, that's Polaris, the pole star. That's the solar system. This is an image of the Milky Way galaxy on edge and the location of the solar system, the pole star Polaris, and the star Vega. And you can see right there, there's the solar system, the Milky Way galaxy from above, and then there's the Milky Way galaxy on edge. And that undulating line again shows the motion of the solar system as it moves around the Milky Way galaxy. And there's the images also of the travel of the solar system in spiral circular motion around the Milky Way galaxy. And there you can see. And there is Jim Dennon's plate, which shows the North Star in the center, the Serpent's orbit of the solar system, number 1, and in these other circles are other solar systems and their planets in orbit. And again, at the time Oahspe was written in 1881, they were not aware of or had not discovered that there were other solar systems with planets in orbit. And right here, you can see the Milky Way galaxy with sub-vortices within it. The Milky Way galaxy is a vortex itself, and these little oval circles inside of this image are sub-vortices. And right here is an enlargement of the sub-vortices, which you notice look just like the whole vortex. So this is a fractal pattern on different scales. The sub-vortices are a fractal of the galactic vortex. So above illustration shows galaxy with sub-vortices within it. Every vortex contains sub-vortices. From pages 235, 236 of the universal cycle theory, which I covered before. And the solar motion on top of its circular orbit around the center of the galaxy. Of course, the sun won't keep on going in this direction forever. In fact, we approximate its motion by an epicycle on top of the mean motion around the galaxy. And I have a link to that from Cornell University. Our solar system, the sun in the Milky Way. How often does the sun pass through a spiral arm in the Milky Way intermediate? And you can click on that and read it if you want. And then this is from definition of epicycle geometry. A small circle whose center moves around the circumference of a larger circle, of a larger one. So the small circle would be the subgalactic orbit of the solar system, whose center moves around the circumference of a larger one. In this case, the galaxy would be the larger one, the Milky Way galaxy. And I covered this image before, showing the North Star in the center of the Arctic Circle, which is similar to Polaris, the North. This is the North Pole in the center of the Arctic Circle, which is similar to the North Star Polaris in the center of Cevorkum. And there are some other things that I've shown previously on my other videos. And scrolling down. Now, in regards to the light, or the so-called travel of light or speed of light, the speed of light in a vacuum, commonly denotes c, is a universal physical constant important in many areas of physics. Its value is 299,792,458 meters per second. In imperial units, this speed is approximately 186,282 miles per second. And that's from Wikipedia, speed of light. Okay. And then I wrote, C indicates the constant speed of polarization in a vacuum. The denser the material, the longer infinitesimal time it takes to polarize the corporal needles in solution. Oahspe said, light is polarity of corporal needles. The flash required a certain time to polarize these infinitesimal needles. Such lapse of time is called the travel of light, the speed of polarization of corporal needles in solution to our senses, where we don't see them anymore. Like when you put salt or sugar in water and it dissolves and you no longer see it. Although all the material is still there, it's just broken down into smaller form to where we can't see it anymore. Flash is a sudden, intense burst of radiant energy. Now, Oahspe said there is a certain time to polarize, and that lapse of time is called the travel of light, the travel of polarization of corporal needles in solution. Travel equals to polarize the adjacent area of space, then the next area of space, etc., so on and so forth. This certain time to polarize the corporal needles has been accurately measured, and that lapse of time is called the travel or speed of light, the constant c speed of polarization, according to physicists. A light year is a polarization year. And of course, here in the Book of Knowledge, Oahspe Book of Knowledge Part 2, it talks about Tae, verse 32. Yes, I measured the stars in your firmament, verse 33. I have measured the light and computed or calculated the time of its coming. And the footnote here in the Oahspe Standard Edition says, i.e. computed how long it took the light to travel, in quotes, from star or stars to Earth. So that verse about the so-called travel of light and the lapse of time it takes to polarize the corporal needles, that's in the Oahspe Book of Cosmogony and Prophecy. Now, here I write mathematical work showing the distance to the North Star and calculating the speed of our solar system around the galaxy and utilizing the circumference formula, pi times radius, distance to North Star, squared to arrive at a grand 4.5 million year circuit that we actually pass through and has a direct impact on us versus the 25,920 years astrological precession of the equinoxes circuit that happened trillions of miles away that does not affect us here on Earth, but sometimes may synchronize with Cevorkum arc cycles and sub-cycles and rules of prophecy. Now, mathematical proof of Cevorkum. Cevorkum theorem of Oahspe. A rigorous mathematical argument. This is the definition of a proof. A rigorous mathematical argument which unequivocally demonstrates the truth of a given proposition. A mathematical statement that has been proven is called a theorem. A theorem is a statement that can be demonstrated to be true by accepted mathematical operations and arguments. What is a proof? A proof is a method of ascertaining truth. But what constitutes a proof differs among fields. From the Massachusetts Institute of Technology course, Mathematics, and then scrolling down. Okay, Cevorkum mathematical formula that I came up with in February 10th of 2003. And I'll try to show you the references to the numbers that I'm using here. Speed of solar system around galaxy, 420,000 miles per hour. Distance to Polaris, North Star, 434 light years equals radius. Orbit or circumference of a circle equals radius times 2 times pi, 3.14159. Cevorkum or circumference equals pi times diameter. That's the equation for Cevorkum or circumference. Equals pi times diameter equals pi times 2 times radius. And here's the figures. And I came up with a calculation of 4,359,047 years circuit, or rounded to approximately 4.4 million years. And that's based on the light years distance to Polaris, and then the total light years of the Cevorkum circuit, and then calculating how much faster light is versus the solar system speed, and then convert to solar system speed, and then using division here. And the 4.4 million I came up with is close to Oahspe's 4.5 to 4.7 million. So my calculation of Cevorkum, based on astronomical calculations and geometrical formula, equals 4,359,067 years. Divide that and you get divided by the 4,700,000, and you get of Oahspe's number, you get 92.74% same. You divide it by Jim Dennon's number, which according to Oahspe scholar Jim Dennon, Cevorkum is 4.6 million years, 4,608,000 years. You get 94.59% the same, dividing the figure that I came up with by Jim Dennon's number. So 5.41 to 7.26% is an acceptable margin of error or variation over such an enormous, over 4.5 million years period of time. And under margin of error, under Wikipedia, It says light confidence intervals. The margin of error can be defined for any desired confidence level, but usually a level of 90%, 95%, or 99% is chosen, typically 95%. This level is the probability that a margin of error around the reported percentage would include the true percentage. In regards to the right here, a common mistake for Oahspe readers is to think that Oahspe does not account for the travel of light. Book of Cosmology and Prophecy, Chapter 1. But that which is called light is polarity of corporeal needles in solution caused by the lines of vortexia. In experiments on Earth, the flash requireth a certain time to polarize these infinitesimal needles, and for convenience sake, such a lapse of time is called the travel of light. Now, what Oahspe calls light is when it's polarized. That would be like a line stretching from one pole to the next pole. It's all one line and it doesn't travel. But in the construction of the line from one pole to the next pole, there is a lapse of time and a travel to go from one pole to the next to complete the line. But Oahspe doesn't consider that light yet until it's all polarized, all in one line, the needles all pointing in the same direction. That's light, also called harmony, when everything is lined up and the same. That's called harmony. And disharmony is when everything's pointing in different directions, chaos. So the construction of that line is what scientists measure as the speed of light, how long it takes to construct that line of light. And Oahspe says it's not light until it's all constructed, all pointing in one direction. So therefore, there's no lapse or travel. Like you wouldn't say that a line that stretches from one telephone pole to the other traveled. It's all one line. So that's the difference in definition. But the so-called travel of light, so-called by man, has been measured. It takes a certain time to polarize those infinitesimal needles and get them lined up in harmony in one direction. And so that's what scientists call the speed of light. Now, Earth scientists' ability to calculate the distance to the sun and stars and planets has greatly improved, much more accurate since the time Oahspe was published. And here I have a link, and I'll click on it right here. It's called The Most Distant Astronomical Objects. List of the most distant astronomical objects. And it shows different astronomical objects. And then it gives dates also, and their measurements. And right here, this article documents the farthest known astronomical objects and the time periods in which they were so classified. Sourced from World Heritage Encyclopedia. And number 1, list of the most astronomical objects. 2, list of most distant objects by type. 3, timeline of most distant astronomical object record holders. And it has here Arcturus, Alpha Bootis star, 1891-1910, 160 light years. This is very inaccurate. This number is wrong, originally announced in 1891. The figure was corrected in 1910 to 40 light years. From 1891 to 1910, it had been thought this was the star with the smallest known parallax, hence the most distant star whose distance was known. Prior to 1891, Arcturus had previously been recorded of having a parallax of 127 mass. Then you also have Capella star, 1849, 72 light years. And then there is Polaris, the North Star, Alpha Ursae Minoris star, 1847-1849, which is the time of when Oahspe was written. It says 50 light years and 80 mass. This is very inaccurate. At the time of Oahspe, 1881, the most distant star or stars that man had measured in light years was the star Capella, Alpha Aurigae, at only 72 light years. So the concept and science of measuring the distance to stars millions of light years away was far ahead of the time of 1881. At the time of Oahspe, 1881, man thought that Polaris was only 50 light years away, instead of the correct number of 434 light years away. If Newborough, and then there's some skeptics who claim that Newborough copied his information from scientific journals already in existence. But if that was the case, if Newborough had used the 50 light years distance to Polaris, the radius of Cevorkum, he would not have been able to come anywhere near the 4.7 million years number for the Cevorkum circuit of the sub-galactic orbit of the solar system that's written in Oahspe. There is no way Newborough could have came up with the 4.7 million years number, which is within 5 to 7% accurate according to modern astronomy and math, for the sub-galactic orbit around Polaris, using pi times radius times 2 plus speed of solar system around galaxy. This is more evidence that Newborough was in contact with a source that was far ahead of the knowledge of man on Earth. Using the 1881 math and science for the distance to Polaris, 50 light years, Newborough would have came up with a Cevorkum circuit number of approximately 502,300 years, or 551,470 years by Oahspe's number. Both numbers are way off. It is as if Newborough was in contact with someone recorded by scientists at the time. So this refutes that Newborough copied his scientific information in Oahspe from previous sources, published scientific journals. So that is it for this video podcast. Thank you for watching and listening, and stay tuned for the next one.